Now let's look at question number 1 in the topic of pressure measurement. The question says an open water tank up to a depth of 2 meters has water in it, and above it has an oil of specific gravity 0.9. Okay, and the depth of the water of the oil is 1 meters. Find the pressure intensity at the interface of two liquids and at the bottom of the tank. So that is the figure you would like to refer to. So you have a depth of 2 meters with water, and on top of this you have oil with a depth of 1 meters, and the specific gravity is 0.9 for this, and for water it is 1. Okay, we need to find the pressure at the interface of two liquids, that is at point A over here, and at the bottom of the tank, which is at point B over here. Okay. Now for the first part, the depth is this much. Okay, so whatever pressure you have at point A is due to this liquid column, and that is the density of oil into gravity into this height, which is 1. What is the density of oil? It is the specific gravity into the density of water into 9.81 into 1. Okay, so when you calculate this, the density comes out to be 900 into 9.81 into 1. That gives you a value of 8,829 pascals. So this is the pressure intensity at this very point, which is at the interface of the two liquids. Now if you come to the bottom of the tank, for this there are two kinds of liquids. One is the liquid height of the oil, that is putting some pressure on the interface, plus you have some liquid column height for water, that is putting pressure on point B. So to find out pressure at point B, you will have to add the pressure at point A, which is due to the liquid column height of oil, plus I will have to add the density of water into gravity into 2 meters, right? So that will be 8829, which we have already found out, plus the density of water is how much? 1000 into 9.81 into 2. So when you do the magic with the help of your scientific calculators, this would be equal to around 28,450 pascals, or 449 to be exact. Okay, so this is how you look at a question, which is very easy. The point to understand over here is that you have to recognize the point where the pressure has to be found out, and always take the liquid column above that and use the formula, which is rho g into h. Okay, so I hope you understood this. Now let's move on to question number 2.